In lesson 4.4, we will be talking about scientific notation. So numbers that do not contain exponents are written in standard form. So standard form is when we have no exponent, it's just the number. It can be very large, very small. However, when you deal with very large numbers like 12,760,000 or very small numbers like the decimal here, it can be difficult to keep track of the place value. A number that is expressed as a product of a factor and a power of 10 is written in scientific notation. When a number is expressed in scientific notation, the exponent tells you how many places to move the decimal point. So scientific notation is all about moving that decimal point. Down in our key concept box here, a number is expressed in scientific notation when it is written as a product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. So what that means is we are going to see a number here. Must see a number there, but just one digit, point, and then however many digits we have behind it. Must be a digit here though. You must have one digit there. So 8 times 10 to the n, where a is between 1 and 10, and n is an integer. That's our symbols. Some examples here. 3,500,000. So we know we're going to have one decimal point. So our 3.5, and then we would count. We move that decimal from the end 1, 2, 3, 4, 5, 6 in order to get to the between 3 and 5. It's a very large number, so we have a positive exponent. Opposite side here, we've got a very small number. So if I start here and we count 1, 2, 3, 4, 5, because I need to be behind the 4. So we're going to have 4 times 10, and since it's a small number, it will be a negative 5 there. Alright, so using those examples, let's go through a few of these here. Express each number in standard form. So 4 times 10 to the second. This 10 to the second is positive 2, so we're going to move the decimal 2 to the right. To the right. It's currently, we want to think about 4.0. So 4, it's right there. We move it 1, 2, fill in our empties with 0. So our final answer there is 400. 5.94 times 10 to the 7th. That would be 7 to the right. So we have 5.94. It's currently right here. So 1, 2, 3, 4, 5, 6, 7. Fill in our empties with zeros. And then maybe rewrite it so it's a little cleaner. So 5, 9, 4, and I see 1, 2, 3, 4, 5 zeros. Throw in some commas. So 59,400,000. And our last one here, 1.3 times 10 to the negative third. It's negative, so that will be 3 to the left. So 1.3, currently right here, we move 3 to the left. So 1, 2, 3, decimal there, fill in with zeros, and then we rewrite it to clean it up. So 0.0013. Okay, so that's given scientific notation. Write it in standard form. Now, if we give you standard form, we want to write it in scientific notation. So 900. Decimal goes after our first non-zero. How many did we move it? 1, 2. It's a large number. So 9 times 10 to the second. And our next one, again, start at the end. We go 1, 2, 3, 4. So that we get behind our first non-zero. So 1.89. You do not have to write the zeros in. Times 10 to the, how many 10s did we move? 1, 2, 3, 4 times, and it's a large number, so a positive 4. And then our last one, decimal is currently right here. We count it 1, 2, 3, 4, 5. So that we get, after our first non-zero, 6.4 times 10. We moved it 5, but it was a small number, so 10 to the negative 5. So notice here, negative just means it's very small, positive means it's very large. Okay, now we want to apply this idea to compare and order numbers. To compare and order numbers in scientific notation, first compare the exponents. With positive exponents, the number with a greater exponent is greater. If the exponents are the same, compare the factors. So So the table shows different geological time periods. Order the time periods from oldest to youngest. So step 1, we want to order the numbers according to their exponents. Okay, so oldest, we're looking for our largest exponent. Let's see, we have an exponent of 8 here, an exponent of 8 there, and an exponent of 8 here. And then we have 1 left over with an exponent of 7. So oldest, we're looking for that largest exponent first. Well, since I have 3 8s, now we have to compare our digits. I see I have a 2.08, 4.38, 2.45. So which one would be the largest? That would be this one. But we're comparing time periods, so we want to write out the words. So we've got the one with an S first. Okay, so he's out. Now we compare our other 8s. We've got 2.45, 2.08, 2.45 is larger, so next would be Triassic. We've got one more exponent of 8 left, so that's our Jurassic. It's the only one that most of us even remember. And the last up, exponent of 7, so that's the most recent, that's our smallest number. So our Tertiary would be last. All right, and we just double check here. Yes, we got those in order. Awesome, right there is section 4.